Hello everyone, welcome to our next lecture. So in this lecture, we're going to use our first sensor. We're actually going to use a sensor called LM35, which is a temperature sensor, and it is one of the most widely used temperature sensor in any embedded system. So without further ado, let's get started. So on your screen right now, you can see what the LM35 looks like. It is a relatively simple and small sensor, and it has 3 pins. The VCC pin, which can take voltage between 4 to 30 volts, and we'll be connecting that to the Arduino Uno, the 5-volt pin. Then we have the ground pin, which will be connecting to the ground of the Arduino. We also have an output pin, which we will be connecting to one of the analog channels on the Arduino Uno, say A0. A0 refers to A0. So the way it works is that it gives an analog signal to the Arduino Uno, which converts it into a value between 0 and 1, 0, 2, 3. And then with the formula, you can convert that value into the temperature in degrees Celsius. So this is the formula on your screen right now. So basically, the temperature in degrees Celsius is equal to whatever value we're getting into 500 divided by 1023. So let's actually write the code down and also discuss the circuit diagram. So here we are in a completely new environment called Fritzing, which is dedicated to making circuit diagrams in electronics. So it has I would say, a bigger library of components as compared to Tinkercad, and that is why we are using this software. Although we cannot do simulations here, but that is just a drawback. So let's get started with the circuit diagram. So first of all, I'll be searching for an Arduino Uno and actually dragging it in to our workspace. So this is our board. We're also going to search for an LM35 sensor. So this is what a sensor looks like, and as you can see, it has a VCC input voltage, an output voltage, which is basically the value, which is the output that we'll be getting on the A0 channel, and ground. So let's actually make the connections here. We'll be connecting 5 volt to our VCC pin. We'll also be connecting the output of the sensor to A0, and we'll be connecting ground to ground. So let me just clean this up a bit. So this is our circuit diagram. We'll also be making sure that the colors are red for VCC, and for ground they are black, and for signal wire we can always let it be blue. So this is how our circuit diagram looks like, and let's actually move to the code section now. So what will be happening over here is that the LM35 will send its analog signal to the Arduino Uno, which will get converted into the digital signals, and we'll be getting a value between 0 and 1023. And with the formula that we discussed before, we can actually convert this data into a meaningful temperature in degrees Celsius. So here we are in the Arduino IDE, where all the magic will be happening. So let me just start off with the code. So first of all, what do we want to do? You always want to initialize serial communication. So for that, we'll be writing serial.begin 9600 semicolon. So now we're going to use the same method that we used and store the sensor value by using the analog read function into a variable. So this time we also have to do an added function that is actually convert that very number to a meaningful temperature in degrees Celsius using the formula that we discussed before. So we'll be actually creating 2 variables. So let's make them int temp and maybe int var. So in the loop section, we'll be first assigning the value temp to the analog read function. We're going to write A0. Next, we are going to convert this value to a meaningful temperature in degrees Celsius using a formula. So the formula is var is equal to temp star 500, and we'll be putting this in brackets and dividing this all by 1023. This looks good. And now we'll be printing on the serial monitor, serial.print. We'll be printing temperature. So I'm just giving it a cleaner look. Note how I have not written ln, so that the next statement is in the same line. So serial.print r var, and we can write ln over here and actually make our way to the next line. So this code looks good. I'll just reiterate what's happening over here. So we're creating two variables, one to store the value that we get directly from the sensor to the Arduino Uno board, and the other to store the meaningful temperature in degrees Celsius that we are converting using a formula. And then we're actually printing the value which we have converted to a meaningful temperature, that is var, on the serial monitor, basically giving it to the serial port, and we can always print it on the serial monitor, check it out over there, or maybe go to the serial plotter and see how the graph varies over a certain amount of time. We will also be giving a delay so that the sensor functions well and the values are much better. So we'll give a delay of 1000 milliseconds. So one of the interesting things that we can do here is interface it with the relay. We'll be learning what that is and create a fan which is smart in the sense that every time the temperature is lesser than say 30 degrees Celsius, we will actually turn on the fan automatically using our program. And stuff like this we'll be actually doing in our next section, where we will learn what a relay is and learn about quite a few sensors and their interfacings with the Arduino Uno board, and how we can actually make full-fledged systems that are just very, very useful.